All right, so today we're going to start looking at chapter 2, and we're going to focus on polynomials. So we're going to learn different features about the graphs, how we can tell how many times it's going to cross the x-axis, and kind of the general behavior of polynomials as x gets really big towards infinity or negative infinity. Okay, polynomials have a lot of predictable behavior, things you can figure out without even graphing it, okay, just by looking at a formula. So let's start with that. We'll graph it. And I want to figure out how many times it crosses the x-axis. All right, so I've got 2x cubed minus 3x squared minus 3x plus 2. Okay, I'm going to start with a standard window, and I'll go from there. All right, so let's see how many times does it look like that graph crosses the x-axis. Yeah. Okay, so when you graph, try it on your calculator, but it should look just like that, and it should cross it 3 times. Any questions on getting that graph?
Wait, how do you do the cube?
Just a caret right below clear and then a 3. Yep. What's the y-coordinate at any of those 3 points where it crosses the x-axis? What would be the y value of the coordinate? Yep.
0?
Yeah, it would be 0. Okay, anywhere that it crosses the x-axis, that's where the y value is 0. Now, how could I show that what I have written here is actually exactly the same thing as what I have written up here? There's 2 ways. Well, there's one way that I could suggest that it's true, and then there's one way I could actually prove it's true. Yep.
I don't know, it's good though. I'm just wondering, I wrote the exact same thing and my graph is on my top.
Did you, and you did zoom 6?
Yeah.
Wait, can we see your graph again?
Yeah.
Okay, cool. I got it.
Okay, so 2x cubed minus 3x squared minus 3x plus 2. So, did anybody have a thought how I can show that this is basically factored form? How did that come from what I have up above? How could I prove it? Yeah?
Well, assuming you can graph each of those and then see where they cross the x-axis, and if it's the same.
All right, so what we could do is we could graph this, graph the other one, and see if the graphs look the same. That doesn't prove they're the same. Okay, they might look the same in the screen, but who knows when x is 1,000,000 if something's a little different. Okay, so we can use a graph to kind of investigate it, but it doesn't really prove anything. So we can do x plus 1 times 2x minus 1 times x minus 2. Okay, and based on the picture, it looks like they're the same. Okay, it did trace right over it. But there's really only one way to prove it. And what would I have to do with this to prove it's the same as what's up above? I'd have to distribute it all up. Okay, so I'll do that real quick. And I get 2x squared minus x plus 2x minus 1. That's what I get when I distribute the first two. Now I need to distribute the last one, and hopefully I get what I have up above. So we get 2x cubed plus x squared minus x minus 4x squared minus 2x plus 2. Okay, let's combine like terms. We get 2x cubed. What's x squared minus 4x squared?
Two 2x squared. 3x 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 squared.
no, not 3x squared, negative 3x squared. And then negative x, take away 2x, so minus 3x, plus 2. Okay, so if we look up 2x cubed minus 3x squared minus 3x plus 2, I just proved that these are exactly the same thing. A little harder to figure this out on your own, though. Okay, this is factoring, but it's factoring with a little bit higher degree polynomial, and it has 3 sets of parentheses, not 2. Either during this chapter or into the next one, you will be able to do that. Okay? Especially if it's nice answers. If they're messy answers, that makes it hard. But these are all very nice numbers, like plus 1, minus 1, minus 2. All right. So one thing we can do is, if we know how to get this, we can find where it crosses the x-axis very easily. The key is figuring this out. For now, don't worry about how I figured that out. Okay? But just take it, we have it. And I want to set that equal to 0 and solve it. So I've got x plus 1 times 2x minus 1 times x minus 2 equals 0. Okay? This is where f of x would normally be. And remember, f of x is y. Okay, so I'm letting the y value equal 0, and I'm finding the x value. We just said earlier, if you let the y coordinate equal 0, that's where the graph crosses the x-axis. Okay, so any questions on why, if I solve this, it'll tell me where it crosses the x-axis? Right, now how do I solve this? I have something times something times something equals 0. What does that mean? Yeah?
Can't you just set like all of the individual parts to 0?
Yeah, we set each factor equal to 0, because if you're multiplying 3 things together and getting 0, there has to be a 0 in there somewhere. Right? So either the first factor could be 0, or the second factor, or the third factor. So that means x could be what? Negative 1. What else? 0.5 or a half, yeah. Or 2. Go back and look at the graph. Look at negative 1, look at a half, and look at 0. Negative 1, 1/2, 2. Those are the 3 points where the graph crosses. Okay, so finding x-intercepts is very easy, as long as you can factor. If you can't, then it becomes a little harder, and we can always use a graphing calculator to help us as well. Questions on that? So if you find a number, okay, like in the last problem, we found 3 numbers. So if you find a number that is a solution to the equation f of x equals 0, then that point, that number comma 0 is called an x-intercept. So like in the last one, we had, what, 2 comma 0, was it a half comma 0, and we had one other one. Okay, another name for an x-intercept is a root of the equation, or it's also known as a 0 of the equation. And if you go on your graphing calculator, under the calculate menu, it can calculate zeros for you. Did we already look at that? No? So if you wanted to calculate a 0 on the calculator, you go to the calculate menu, pick a point somewhere to the left, and it can only do 1 root at a time of your root. Pick a point somewhere to the right, hit enter. Now do a guess. And it tells me that it crosses the x-axis at 0.5 comma 0. You have to do that each time, once for each root. Yeah? So when you go second, calc, 0. Pick a point to the left and hit enter. Pick a point to the right and hit enter. And then make sure the guess is close to the root. Anyone still having a problem with it?
This is x equals plus.
X, are you using one of my calculators?
No.
No? So I'm not sure because I don't know everything on your calculator. I know it's the same model, but you might want to try one of mine
Okay.
for today. And then if you want, we can look at yours after and try to figure out maybe there's something set wrong.
Okay.
Could be a million different things. Yep. Okay, so on my calculators, it calls it a 0. On the older graphing calculators, it did use the term root. When you went to second calculate, it used to say root. So they changed it. Okay, for a linear equation, okay, that's not horizontal, okay, but for a linear equation, there's only one root. Okay, because a line can only cross the x-axis one time. And if you have an equation in this form, ax plus b equals 0, very simple way to find the root is just negative b over a. It's basically just getting x by itself. Subtract b and divide by a. So that's a shortcut, but it only works for linear equations. Okay, we also have a shortcut that works for quadratics. It's a quadratic formula. But beyond that, we really don't have any formulas that we use in this class to find roots. There is a formula for cubics. Okay, it's a step above the quadratic. It's called the cubic formula. But it gets extremely difficult. All right? It's not just like it's a little harder than quadratic. It's a lot harder. So if we have a cubic, what we hope is that we can factor it and do it that way. If we can't, then we would use a graphing calculator to find the roots for us. All right, so what would be the root or the 0 of this equation? 2x plus 3 equals 0. About Kayla? You see the formula up above? Yeah, you're just using the formula, right? If you want to find the root of an equation, you're trying to solve for x. You're setting that, which is y, equal to 0. Okay? Because we said earlier, if y is 0 and you find x, that's where it crosses the x-axis. Okay, so that's where my root is. How would I write that as a coordinate for the x-intercept? How about Trevor? How would I write that as a coordinate for my x-intercept?
That's the x-intercept, so
Mhm.
the y was 0, that would be x
Yeah, and so you would write,
negative 3/2, comma 0.
perfect. Okay, so just be careful how they ask you to write the answer. Okay, if they ask for a coordinate, write it as a coordinate. If all they ask for is what number is the root or what number is the 0, in this case, that's all you have to write. All right, what kind of equation is that? Yeah, that's a quadratic, so it's 1 degree higher than linear. And how many roots or how many zeros can that graph have? What are the possibilities, Josh? Up to 2 zeros. Can it have 1? Yep. Could it have none? Yes. So in this case, quadratic can cross the x-axis 0, 1, or 2 times. How does the discriminant tell me how many times a quadratic equation crosses the x-axis? I think we did this maybe a lesson or two ago. But you can use the b squared minus 4ac, calculate that, and you'll know how many times it crosses the x-axis. You won't know where, but you'll know how many times.
You can tell because it's less than 0, then it doesn't have any zeros, it's equal to 0, and then it's 1 0. It's greater than 0.
Yeah, exactly. Okay, just everyone understand what Josh just said? Comes out negative, no roots. Positive, 2 roots. Comes out 0, 1 root. All right, so this one is asking us to solve. Because it says approximate, that means a decimal is okay. Okay, you do not have to leave a square root in the final answer. All right, who can tell me how I would find my zeros here? What would be my first step? Yep, Francisco. Yeah, we got to get it equal to 0. Okay, you want to get everything on one side. Do you want to put everything on the left or on the right? Okay, so tell me how I would do that. Subtract 2x squared, and that would give me what? Yep. Negative 2x squared, go. Plus 1 minus 2x. Okay. I like to write things in what's called descending order. So what you said is perfect, but I'm just going to write it like that. All right. My next step. Okay. What do I do from here? Not quite as simple as a linear function. About Andrew?
Finally, 0 is still in that.
Sorry, go ahead. What did you say?
Plug in -2 for me,
Okay, I like that. We could let b equal -2.
and then a -2, and then c is 1.
Okay. What's this a, b, and c stuff? Where are you going to plug all this in?
The b squared minus 4ac.
Close. That's part of what we have to plug it into, but that's only the discriminant. I need to use the quadratic formula. Okay, remember, the discriminant does not tell you where the roots are. It only tells you how many there are. Okay, that's all that it tells you. But that is part of what we have to do.
Wait, the negative b square root, is it that one? Is that the?
Yep, the negative b. Yep, what comes next?
Plus or minus
Plus or minus.
square root. And then it's the b squared
Yep,
minus 4ac over 2.
all over,
2.
not 2, 2a, which is, in this case, -4. All right, so when I do this, I'm subtracting a negative, so that's going to become positive. What's my radicand going to come out to? 12 divided by -4. Now, if they wanted an exact answer, the next step would be to reduce this like this. 2 plus or minus 2 square roots of 3 over -4. Any question on how I got 2 root 3? Nope. And then I can cancel a 2 from here, here, and here. So this is the exact answer you would see if that's what they wanted. But they said it was okay to solve it approximately, so I can just take each of those answers and plug them into my calculator. So I've got 1 plus square root of 3. That's my numerator, divided by -2. So that's one answer, -1.37. And the other answer 1 minus the square root of 3 divided by negative 2. 0.37. So this is not a problem we would have been able to factor. We have to use the quadratic formula. Okay, graphing calculator can confirm that these are the decimal answers, but it will not give you this. That's why you still have to know how to do the quadratic formula in case I ask for the exact answer, reduced, which is that. Okay, questions on how I got the 2 roots for this quadratic? All right. This part, I just want you to watch. Don't write this down. So before graphing calculators had this second calc, right? They didn't always have that feature. Okay? What you had to do if you wanted to find a root was you had to zoom. It took forever. You had to kind of zoom in, all right? And I could say, well, it looks like there's a root somewhere between 0 and 1. So what I could do is put more tick marks. I don't need to graph both. I could put more tick marks on the screen. Okay, I could go like, let's put tick marks every 0.1. Okay. All right, and now what I'll do is I'll zoom in a little more. Zoom in right about over here. And now by zooming in, I can tell, well, there's a root somewhere between, that's 0.1, 0.2, 0.3, 0.4. It looks like it's right on 0.5, okay, which is 1/2. And what was even worse is if it didn't cross right on a tick mark, then you have to keep zooming in and adding more tick marks and then try to figure out what 2 tick marks it was between and get an answer the best you could. Right? We don't have to do that anymore. Since we've got this menu, we can just use second calc 0. Right? So that's the feature that we use now. But if you look at the front of your book, actually it doesn't show it on there, but I think there's certain times in your book where they mention using a graphing calculator. And this book was written actually quite a while ago. It's when they had TI 81s. So right now we're using the 84s. But there's a picture in here somewhere of a TI 81. All right, so let's try to solve this one. Okay, this is a cubic equation, so we don't have a cubic formula that we know. So how can I find the roots of this equation? It's actually 2 ways I can do it. One way involves pretty much typing it in the way you see it. The other way involves rearranging it a little bit, kind of like we did the quadratic. Well, Amanda? All right, we could try to factor, but we can only factor when it's equal to 0. So the problem, yeah, we could factor, but it won't help us here. Okay, so that's one way to do it. And can you keep going and tell me what I would do now? Yeah, we're going to put that in the calculator now. X cubed, oops, plus 2x minus 1. Okay, I'm going to do zoom 6. Okay, you've got a picture of it on the screen. And what would I do now? About Hila? Yeah. Second calc 0. Pick a point to the left. Pick a point to the right. Take a guess. And I get a not so nice answer. Okay, about 0.453. So that's one way to do it on the calculator, using a 0. Does anybody know another way I could have done this? And we did this method earlier, leaving it just the way it is in step 1. There's another feature under calc that we've used before that would help us find that 0. Yeah, a couple people said it. Yep. Intersect. How would I do this problem as an intersect rather than as a root? Tell me what I would type in.
You said you take both of them and both sides are different for different lines.
Yep, we're going to type, let's say you put the left side in y1, put the right side in y2. Okay, hit graph. And now we're going to look where these cross. We're not calculating a root anymore. So second calc intercept. Pick a point on the first curve, point on the second curve, and they only cross once, so just take a guess, and you get 0.453 again. Okay, so 2 different ways to get exactly the same answer. Any questions on doing it either way, either with an intersect or a 0? Okay. So let's look in a little more detail at third degree polynomials. Okay, so degree 3 polynomials have the form ax cubed plus bx squared plus cx plus d. A, B, C, and D can be any real numbers that you want. They cannot be imaginary. Except A cannot be one special number. Anybody think they know what value A is not allowed to be? Because if it was this value, you wouldn't have a cubic, you would have a quadratic. 0. Okay? If you make A 0, you just wiped out the cubic term. So A, B, C, and D, any numbers that you want that are real, except A can't be 0. Okay, page 80 shows what I'm drawing right here, but these are the different types of cubics. Okay, I think in the last problem we saw a cubic that kind of looked like this one all the way on the left. It never really did a turn back. It always kind of kept going up. Kind of did a little start of a turn, but it never really fully made the turn. Okay, so those are the different kinds of cubics you can have. So how many times can a cubic cross the x-axis? At most. Tom? 3. Yeah. There's your x-axis. Okay, it could cross 3 times. Could it cross twice? Yes, it could cross twice if you had a cubic that maybe did something like this. That could be twice. Could it cross once? Sure, that's the last problem we just did. Is it possible that it never crosses, like a quadratic? No. Okay, one characteristic of a cubic is that it goes up forever and down forever, and it's always connected. Well, if you go up forever and down forever, and it's always connected, it has to go through 0 somewhere. In fact, that's true for any odd degree polynomial. They always have to cross the x-axis at least once. Right, so let's take a look. This one. Okay, they're asking us just to find how many solutions this has. Okay, it's a cubic, so how many could it have at most? Yep, could have up to 3. It might have 2, it might have 1. Guarantee it doesn't have 0. And remember, when I say solution, I'm talking real solutions. Okay, I'm not getting into imaginary solutions today. All right, so we have x cubed minus 5x squared plus 6x minus 1. It's already equal to 0, so I'm just going to leave it that way. Type it in. Let's see how many times it crosses the x-axis. Okay, sometimes you have to zoom in if it looks a little questionable. I don't think this one is questionable. How many times does it cross? 3 times. Okay, now they want us to find just one of the roots. Okay, we'll find the one that's in the middle. Okay, so take a second. See if you can find the middle root. Anybody think they got an answer for that middle root? How about Jeff? Did you get that?
Yeah, I got 1.55.
Let's check it out. Yep, I also got 1.55. Good. Okay, any questions on that one? All right. Okay, so that basically finishes up section 2.1. And we'll take a look at just part of section 2.2, but we won't finish it today. All right, so kind of a reminder, we've talked about this before, and you don't have to write that if, it's just, basically it's just saying when we solve a problem, usually one of the 2 methods we use is either graphing or algebraic. Okay, so sometimes we've used algebraic today when we did quadratic formula. We've also used graphing when we've done second calculate. So those are usually the 2 methods that we use quite a bit when we're solving a problem. All right, so let's take a look at this. Okay, it says Bill invests $20,000, and he's going to make an investment in 2 different accounts. One of the accounts he invests in is going to earn 6.75% interest. And the other account he's going to invest in earns 8.6% interest. Okay, and he's going to split up that $20,000 between the 2 accounts. Okay, maybe the 8.6%, if this wasn't simple interest, I would say something like, maybe the 8.6% is more risky, but it can make more money. And the 6.75%, you don't make as much money, but maybe it's more stable. Because you certainly would not get interest rates like this in a bank account. Nowhere close. But just for our problem. If you don't know the formula for simple interest, I will give that to you. Okay, it's I equals PRT. It's not the formula that banks actually use, but I'm using it because it's a little easier. Okay, it's simple. And in that formula, there's 4 variables. I is your interest. P is your principal. R is your rate. And T is the time. I'm going to make sure when you use a rate, we always change percents to decimals in this formula. Okay, how many had already seen this formula now that I reminded you of what it is? I equals PRT? Yeah. Okay, so I want to find an algebraic representation of the interest that, who is it, Bill or someone? Bill's going to earn in 1 year. Okay, so I definitely need a variable. And what's the variable going to represent here? Okay, because I know like interest rate, I know the time is a year, so R is not a variable, T is not a variable. What do I need a variable for, Alan? Right, we know he has a total of $20,000, but we don't know how Bill's going to split it up. So let's assume that he invests X dollars at 6.75%. Okay, so now he's earning interest from two separate accounts, one that pays 6.75%, one that pays 8.6%. I'm going to find the interest he earns in each account separate, and then I can find the total interest earned in both by doing something with each individual interest. Okay, we'll do that in a second. So let's start at 6.75%. The interest Bill is going to earn here is the amount of money invested times the rate times the time. How much money does Bill invest in the 6.75% account? X. Principal? What's the rate in this account as a decimal? Yep.
0.0675.
Good. 0.0675. And how many years is Bill leaving his money in this account? 1 year. So in this case, time doesn't have much of an effect. And I'm going to write this how we would normally write an algebraic expression. I'm going to put 0.0675 as a coefficient. That's the interest at 6.75. All right, let's do the same thing now to find the interest at 8.6. All right, how much money, what's the principal that Bill invests in the 8.6% account? Yep. Careful, not X, because X is how much he invests in the other account. Well, since we know the total amount of money he has and we know how much he already invested, we can figure out how much is left. The total, okay, minus X. That's the principal he invests at 8.6. How about the rate? Somebody tell me the rate as a decimal? 0.086. And again, the time is 1 year. Now to simplify this one, what property do I have to use? Yeah, I've got to distribute this out. Okay, multiplying by 1 isn't going to change 0.086. So I've got 20,000 times 0.086. That's 1720 minus 0.086x. There's his interest from the second account. Now, what would I do with each individual interest to get the total? Yeah, add them together. So the total interest is 0.0675x plus 1720 minus 0.086x. Anything I can do there to simplify that expression a little bit? Yeah.
0.0675.
Yeah. Minus 0.086. So I can combine like terms. Let me just double check. I think I did that right. 0.0 minus 0.086. Okay, so we get negative 0.0185 x plus 1720. Okay, there is our formula for total interest after 1 year. Questions on that? That's all they wanted. They're going to have us do something with this in a second on the calculator.
That's a total interest.
Yep. If you tell me how much money he invested at 20,000, like say he put $13,000 in that account, I would fill 13,000 in for X, do out the arithmetic, and that would be his total interest. Yep.
No, like I think it's spelled wrong.
You think what?
Isn't it TOTAL?
T-O-T. Oh, yeah, I just didn't quite sorry. Yeah.
I don't know. It was just like. Well, I thought it was like spelled different in math.
Well, felt the same way. All right, so what's the difference between when we're finding a complete graph? Okay, so we know that means x min, x max, y min, y max. What's the difference between finding a complete graph of, say, an algebraic representation, okay, versus a problem? So I mean, problem situation means I want you to think about it in the context of a word problem. Algebraic, I just want you to think about it as a pure equation. Forget what anything represents in it. It's just letters and numbers. What's the difference between thinking about it these two different ways? Tom?
In reality, there are some restrictions, so maybe it can't be negative in reality, but
Yeah, exactly. Okay, when you think about something that's part of a real word problem, okay, you have to take into account restrictions, like maybe there's no such thing as negative time, negative distance. But if you have an equation, okay, in theory, I could plug in any value I want for x. I could plug in -1,000,000, and I could calculate what comes out on the other side. It doesn't make sense in this problem because of the situation we're looking at. There's also other restrictions, okay, like x in this problem can't be bigger than what? There's an upper limit on x. What is it?
For what problem?
For this last problem. What's that upper limit on x here? Right. You can't invest more than he has. All right? So even though I could plug in 50,000 and get an answer and tell you, it's not going to come out undefined. It doesn't make sense in this problem. So I want to know how much Bill invested in each type of account if he ended up earning this much interest. Okay, thoughts on how I'm going to figure that out? And I could do an algebraic method, but I'm going to use the graphing calculator. Well, what do I need before I can even use the graphing calculator? Yeah, I have to have an equation that I'm going to plug in. Okay. Can anybody tell me what my equation would be? How about Zach? What does that 1509 represent?
That's the total interest.
Exactly. That's the total interest that was earned. Okay, so do you see anywhere we could use that in what we did previously?
You do 1,509.10 equals
Yep.
negative 0.0185 x plus 1720.
Yeah. We take and plug that in on the other side of the equal sign, because that's my total interest. And now I solve this equation. Okay, I've shown you guys two ways you can solve this kind of problem. Get it equal to 0 and find a root, or graph separately on each line and find where they cross. Which way you want to do this one? Graph separately. Okay. So does it matter which one I put in y1 and which one in y2? No. Doesn't matter. Okay, so 1509.1. You put the 0 if you want, but that doesn't matter. And then negative 0.0185 x plus 1720. So we already know the most money Bill can invest is how much? 20,000. So that gives me an x max, 20,000. What's the minimum x could be? X. I'll fix that in a second. Thank you. Yeah, the minimum x could be 0 if he doesn't invest any money in the one account, puts it all in the other one. All right, now, he's not going to make negative interest, but we don't know the maximum amount of interest he could earn. Let's just set it at 2,500. Well, actually, we do. What's the maximum amount of interest he could earn? What is it? If he didn't invest, I think if we look at this y-intercept, 1720, that tells us where we're crossing the x-axis, okay, or y-axis. So if x is 0, he would earn 1720 in interest, okay? And letting x be 0 means he invested nothing in the lower interest account and in everything in the higher paying account. So he can't earn more than 1720. So let's just say 1,800. Okay, so notice the more money that he invests in the lower paying interest account, the less money he makes. So we're going to calculate where they cross. And x is 11,400. Okay, what does that represent again? X was the money he invested at what percent? Yep, so at 6.75%, he invests 11,400. So how do I figure out how much was invested at 8.6? Yeah, just subtract that from 20,000. So 8,600. Okay, any questions on that? All right, so last page. All right, and I think we might have done a problem like this in the homework, similar about rectangles with finding perimeter and area. Okay, but this one says, think of all the rectangles that have a perimeter of 100. Find an algebraic representation that describes the area in terms of the width. So in other words, you tell me the width of your rectangle that has a perimeter of 100, and I'll tell you what the area would be automatically. Okay, so what could I label in this picture? I'm finding the area in terms of what? In terms of width. Okay, so I should label, it's not quite a rectangle. In terms of width, there's my width. So what would my length be? And remember, it has to be in terms of width. We don't want to use L. So or even if you're not sure what it is, any thoughts about how I could figure it out? Yep.
Well, you know the perimeter is 100.
Perimeter is 100.
And so if you subtract 2W from 100, you get perimeter. I mean,
Okay, so if we subtract 2W from 100,
one length, and then you divide it by 2 to get the other one.
and then, yeah, take half of it, because we have to take what's left and split it between each one. That's going to give me, can anybody simplify that? 50 minus W. Okay, so now we've got an expression for the length. Now, how do you find the area of a rectangle? Length times width. So length is 50 minus W. My width is W. So if you have a rectangle with a perimeter of 100, this is the formula for the area. So if you said the width is going to be 12, I could just take 12, plug it in for W, and automatically get the area. Does anybody remember what shape gives you the maximum area? Was that the next question? Oh, well, I am going to graph it to figure out what I just asked you. But does anybody remember? Yeah, it's a square. Okay, so let's graph what we have. What shape is that graph? 50w minus w squared. Nope, not a rectangle. It's a parabola. Okay, it's a parabola specifically opening down, okay, not up. What's the maximum my width could be? Definitely not 20,000. The width couldn't be 100. The maximum it could really be would be approaching 50, like 49.9. Because if you go bigger than 50, you've got negative width. Okay, so 50 up to 50 is the maximum. The area, well, this part we don't really know, but I kind of do know because if it's a square, that means each side would be 25. Just think of what's 25 times 25? 625. Just type it in. Okay, so there's your curve for all your different areas. If you calculate a max, it's going to tell you that the maximum does occur when x is 25. And that would give you a maximum area of 625. Okay, they didn't ask for the maximum here. All they really asked for was this and find a complete graph. So write down your mins and maxes. Okay, any questions on that? All right, so a couple reminders I think I already mentioned. Tomorrow we have our first test. Okay, you can use a reference sheet. Okay, again, it has to be just 8.5 by 11 inch. Okay, handwritten. If you need to write on both sides, you can. Just one piece. Graphing calculator, you can use that on the test. Make sure that if you do a reference sheet, it's on a separate piece of paper, because if it's in a notebook, you're going to have to tear that sheet out. So if you don't want to, like if you got homework or notes on the back and you don't want to mess up your notebook, do your reference sheet on a separate piece of paper. Okay, any questions about that? Okay, and I will be after school today if anybody needs extra help. Okay, so the homework, 2.1 is the first section, 2.2 is the second. Okay, so it's page 82. 1 through 5, 8 through 11, 15, 27, 28, 31, 34, 40, and 45. Keep in mind there is a lot of graphing, so you might not have to write anything down for some of these. Just, you can say on calculator. Okay? On page 88, it's 5 through 12, 21 to 23, and 31 to 34. Some of these are just one big problem, kind of like the interest rate one we did with Bill. Find a formula, graph it, and intercept.